Welcome. So, yesterday we talked about arc length and area of a sector. Today we are going to continue with that. So, the first thing we need to do is talk about arc length. Now, arc length comes from our circumference formula. So, circumference equals 2 pi r. And so when we are talking about a sector, our sector is just a piece of our circle. So we need to know what that piece is, and that comes from our central angle. So our central angle in this case is 60. So our angle is going to tell us how much of our circle we are looking for. So our sector arc length, we're going to use S for that. S equals our angle out of 360, that tells us how much of our circle we are looking for, and then that is times our 2 pi r. Now, with this question here, our 60 is our central angle, our radius is 5, and we are looking for our arc length. So arc length is S equals 60 out of 360 times 2 pi times 5. Okay, so 60 out of 360 is 1/6 times 10 pi. So that ends up being 10/6, or 1 67/100 pi centimeters. And just to simplify it, I'm leaving pi in my answer. Oops. Well, that's going to go away anyway in a minute. Sorry, I don't know why it's not sticking around. It just keeps disappearing. So we're just going to go with it. All right, what is the length of an arc if the circle has a radius of 4 centimeters and the central angle is 120? So I recommend pausing the video, try this one on your own, and then resume it to check your answer. But if you want to follow along, that's fine too. So our radius is 4 centimeters, and our central angle is 120 degrees. Okay, so our arc length is 120 out of 360 times 2 pi r, or 4 centimeters. So 120 out of 360 is 1/3 times 8 pi. So this simplifies to 8/3, or 2 67/100, 7 pi centimeters. All right, I hope you got it right. Now, we are going to do our area of a sector. So, we come down here, area of a sector. So, just like our circumference, our area of a sector comes from our area of the whole circle. So the area of a circle, if you don't remember, is pi r squared. Got my equals. Area equals pi times your radius squared. And so our area of a sector, you'll see me write it like this a lot. Area subtext sector equals, just like arc length, theta out of 360, or our angle measure out of 360, times pi r squared. Okay, so in this case, we still have a 60-degree angle, and our radius is still 5, but we want the area of this piece of our circle. our area of our sector equals 60 out of 360 again. But this time we're doing pi times our radius squared. And so 60 out of 360 is still 1/6 pi, and then we did 5 squared, which is 25. 25 pi, 1/6. Not quick enough. Okay, so 1/6 times 25 is about 4 1700. So our area of our sector is just 4.17 pi. And don't forget, area is always units squared. So we have centimeters squared. All right. Now, our second example problem, just like last time, if you want to pause, try it on your own, and then come back and check your work, that is completely fine. I recommend that. If you just want to follow along, that you are more than welcome to do that as well. So we're going to determine the area of our sector. This time we have a diameter of 4. So we have a diameter of 4 centimeters and a central angle of 90 degrees. So our diameter is 4 centimeters. So that makes our radius half of that. So our radius is 2 centimeters. And our angle is 90 degrees. So our area is going to be 90 out of 360 times 2, 5, but our 2 is squared, pi r squared. So 90 out of 360, yesterday you learned that was 1/4 of our circle. So 1/4, 2 squared is 4, pi. Well, 1/4 times 4 is just 1, so our area ends up being just pi square centimeters. Okay, and yesterday I told you I was going to extend this further, and your algebra skills are going to come in handy. So if you flip over to the back